Before we move on to the AC method, I wanted to make sure that everybody got down the last part of step 4. So step 4 for the grouping method should read to put the two terms outside the parentheses into one binomial and what's shared inside the other. Moving on to the AC method. This method is used when the leading coefficient A is greater than 1, as is the case in our examples that we have here. So our first step is going to be to multiply those A and C terms together. And our A term is 3 in this case, and our C term is positive 2. So when I multiply our 3 and our 2 together, I get 6. So then our second step is going to be to make a t-table, like we learned how to do yesterday, of values that multiply this time to our AC product and add to B. So we want multiplying to 6 and adding to our B value of negative 5. So I know that I need to have both of my values negative because negative times a negative is positive and a negative plus a negative is negative. So starting with negative 1 times negative 6, when I add negative 1 plus negative 6, I get negative 7, which doesn't work. So we're going to try another route. The next one I think of is negative 2 times negative 3. And when I take negative 2 plus negative 3, I get negative 5, which is exactly what we're looking for. So now we can go ahead on to step 3, which is going to be to use the values from step 2 to split the B term into two B terms. And so we're going to take 3y squared, which doesn't change, and splitting those B terms up, we have minus 2y minus 3y and then plus 2. The question I know might be coming up of does it matter which of our B terms that when we split it goes first? It doesn't matter. All it's going to dictate is what will be in common between our two methods, because our next step is going to be to finish factoring using the grouping method. So I'm going to group this together by 3y squared minus 2y. I'm going to make this plus a negative 3y plus 2. And when I factor out what's in common, 3y squared minus 2y has a y in common, leaving me with 3y minus 2. And I want to factor out a negative 1 because we want to get this 3y to be positive and the 2 to be negative. And so when I go about this, my binomial I have in common is 3y minus 2. And then what I have on the outside that will make our other binomial is y minus 1, giving me a final solution of 3y minus 2 times y minus 1. Let's try the second example, 2x squared plus 7x minus 15. 2 is our A value, negative 15 is our C value. And when I multiply those together, 2 times negative 15, that gives me negative 30. So my t-table wants me to multiply to negative 30 and to add to 7. Well, to multiply to a negative number, one term must be negative and one must be positive. But to add to a positive, we know that the bigger number has to be positive. So let's start with 30 times negative 1. And when I take 30 plus negative 1, I get 29. And I know that doesn't work. So cross that off and move on to the next one. Next one I think of is 10 times negative 3. And when I take 10 plus negative 3, I get 7. which is exactly what I'm looking for. So then I can go ahead and rewrite my equation. We have 2x squared plus 10x minus 3x minus 15. And so then I can factor by grouping, giving me 2x squared plus 10x in one group, make this plus a negative 3x minus 15 in the other group. In 2x squared plus 10x, I have a 2x in common, leaving me with x plus 5. And then in the other group, I have a negative 3 in common, which leaves me with x plus 5. So then I see that I have x plus 5 in common, which is my first binomial. And the other binomial is going to be 2x minus 3. Moving on to one final example, we have negative 9x squared plus 9x plus 10. There are two routes you can move with this. One can be if you don't feel comfortable working with a negative coefficient of the a value, you can factor out a negative 1. Otherwise, we can work with it. So I look here and I have my a value of negative 9, c value of 10, and when I take a of negative 9 times 10, I get negative 90. So I know that my t-table needs to multiply to negative 90 and add to 9. 90 times negative 1 isn't anywhere near close what we need. So let's try 30 times negative 3. And if you start looking at them and knowing what your options are and that it's not going to work, you don't have to write it down. So then I take 30 plus negative 3, which gives me 27, which is still way off from what I need of our value of 9. So I'm going to move on to another number that's hopefully going to get us a little closer. And I know that 5, so we'll do negative 5, and if I take negative 5 times 18, I get negative 90, and 18 plus negative 5 is 13. So we're a little bit closer, but still not quite where we want to, so we don't want to make a huge jump. So then I'm going to try negative 6, because since I know that 90 is divisible by 2 and 3. I know it's also therefore divisible by 6, and that will give me negative 6 times 15. And if I take 15 plus negative 6, I do in fact get 9. So I'm going to go ahead and rewrite my polynomial. I have negative 9x squared, and then I'm going to actually put the negative 6x first so I don't have to add a negative, plus 15x plus 10. So then I can go ahead and factor by grouping. And in my first term, I can factor out a negative 3x, which leaves me with 3x plus 2. And in the second group, I can factor out a 5, which leaves me with 3x plus 2. So what's in common is 3x plus 2, and what's left over is negative 3x plus 5. Your job now is to complete these two try problems and bring them with you to class tomorrow.